Okay, so today we're going to talk about proportional and non-proportional uh, functions. Okay, so um, and this paper is kind of driven towards proportional, and that's because that's what we're going to start with. But it does touch on non-proportional functions as well, because you need to be familiar with both of them and be able to compare, right? So the first thing is to fill in the definition. So a proportional relationship is one uh, in which a proportional relationship is when one quantity varies directly with another quantity. Okay, and so usually these quantities we say they're independent or dependent upon each other. So one quantity is going to be independent, and then the other will be dependent. So um, in this example here, it says every time you earn 10 stars at Starbucks, you earn a free drink. So every time we earn 10 stars at Starbucks, we earn a free drink. Okay, so um, the drink, the free drink, is dependent upon us getting 10 stars. Okay, so the number of stars, the number of stars is the independent value, and the number of drinks is the dependent value. So again, the number of drinks you get depends upon the number of stars you earn, right? So if I earn 0 stars, then that means I get no drinks. And then we're going to go to increments of 10 because if I earn 10 stars, then I get one drink. If I earned 20, I would get two drinks. I earned 30, I would get three drinks. So the number of drinks depends upon the number of stars I get. Okay, the number of stars I get doesn't depend on the number of drinks I get for free. That doesn't work out. The number of drinks I get free depends upon the number of stars I earn. However, you earn stars at Starbucks, I'm not really sure. So we have a graph here, and so on this graph, on the x-axis, I'm going to go by tens. So I'm going to say 10, 20, 30, 40, 50. We can stop there because our graph doesn't go that far. Um, I'm sorry, our table doesn't go that far. And then for the y-axis, we're going to go by ones. 1, 2, 3, 4. We'll go 5. Right? And so down here, this is called the point of origin, also known as 0, 0. So that's 0.0 drinks, right? And so we can start there because if I don't earn any points, I don't get any free drinks. Okay? If I earn 10 points, I get one drink. If I earn 20 points, I get two drinks. If I earn 30 points, I get three drinks. If I earn 40 points, I get four drinks. And then we can go, if I earn 50 points, I get five drinks. Now we kind of went past our table, but uh, this has a constant rate of change, and that's kind of what we're here. That's what we're here to talk about. The fact that this has a constant rate of change. As I earn in increments of 10, I get a free drink, and it's a constant rate. It never changes. And so if I was to connect these dots, I get a straight line coming from the point of origin. Okay, so this is called a proportional graph. This is proportional. How do I know it's proportional? Because it goes through the origin. So I know it's proportional because it goes through the origin, and the origin's here. So if I'm looking at the graph, I can tell you right away this is proportional because that graph goes through the origin. Now, if I was to look at the table and say, well, how can I tell that that graph is proportional given the table? Well, what I have to do is I have to see, well, what we would like to do is we put the change in y over the change in x. So I look at the y, which is here. What is that changing by? If I go from 0 to 1, what is that changing by? Well, it's changing by 1. So the change in y would be 1. Then I look at the x. So what is that changing by? I went from 0 to 10, or from 10 to 20. What is that changing by? That's changing by 10. And so what we found is the constant. The constant is we have the change in y over the change in x, which is 1 over 10. And so if I wanted to make an equation for this table, I'd say that the y value is going to equal 1 over 10 times the x value. And if you tested it out, you could see that if you put in this x value, 10, well, 1/10 of 10 is 1. If you put in 20 into this x value, 1/10 of 20 is 2. So on. Now, if you're just looking at the table and you're trying to figure out whether or not this table itself is proportional, then what you need to do is you need to do the math for all of them. You do y over x for all of them. So we have 1 over 10 is 1/10, fine. If we have 2 over 20, it needs to equal the same thing as this. We have 1/10 here, then this one needs to also equal 1/10. Does it? It does, because if I simplify, 2 over 20 simplifies to 1/10. If I had 3 over 30, again, that simplifies to 1/10. So it is definitely a proportional table because all of the values, 1 over 10, 2 over 20, 3 over 30, all equal the same thing. So we know for sure that that table is proportional. And we can make an equation to fit this table by simply saying, well, if we take the change in y over the change in x and multiply by the x value, you will get the y value. And it works. We have, if I put 10 as my x value, 1/10 of 10 is 1. Basically, when you say 1/10 of something, you're dividing by 10. So 1/10 of 20, 20 divided by 10 is 2. 1/10 of 30, that means 30 divided by 10 is 3. Okay, so we know for sure that given this equation, it's a proportional graph. Proportional situation. And if you look at the table, if you divide all these numbers, 1 divided by 10, 2 divided by 20, 3 divided by 30, divide all those numbers, they all equal the same thing, so I know my table is proportional. If I look at the graph, I see that this is a straight line and it goes through the origin, and that tells me right away that that is a proportional graph. So if you're looking at the graph, check for the origin. Does that line go through the origin? If it does, it's proportional. If you check the table, divide all the numbers, y divided by x, 1 divided by 10, 2 divided by 20, 3 divided by 30, it should all equal the same thing. In this case, it does. 1 over 10, 2 over 20, if you simplify, it's 1/10. 3 over 30, if you simplify, 1/10. So they all equal the same thing. And then again, if you look at the equation it's just 1 over 10. You don't have to add anything or subtract anything to get this table. It's just 1/10 times x. So we know that that is a proportional equation. So then we have a non-proportional graph. I'm sorry, a non-proportional situation, and it's a very simple way to tell that it's not proportional. First, let's read it out. You pay $25 to join Planet Fitness and $10 a month after that. So before you even use it, before you even start at the gym, you got to pay $25. So the independent value is the number of months. Okay, so the independent value is the number of months because the amount you pay depends on the number of months you use the service, right? So the number of months is the independent value, and the amount paid, let's do another color. The amount paid is the dependent value. Okay, so if I join this gym and I start at 0 months, I'm still going to pay that initial $25 fee. I mean, it's $25 just to join the gym, so I'm still going to pay that $25. Okay, so it's that $25 and then $10 a month after that. So after the first month, right, it's going to be this 25 plus the $10, so that's 35. The second month, I paid $10 more, right? So it'd be 45. And then the third month, I want to pay $10 more, so it'd be 55. So in 3 months, the total amount I paid is $55, right? Before I even started the first month, I had to pay that $25 initial fee. And then the first month passed, I had to pay $10 a month, so $35, including the fee. And then the second month, I paid $45 total because I started at $25, and then I paid 2 months worth of premium, so it'd be $45. And then the third month, I paid 3 months, so it totals out to $55. And so that's how much I paid total. Now, you may be thinking, well, how do I know it's not proportional? Well, first of all, if you look at the table, right? If I was to divide all of these, if I put a y over x, if I put 25 over 0, right? 25 over 0 equals 0. So that means all of these numbers need to equal 0. If not, then it's not proportional. Take this one, 35 y over x, 35 over 1. Why does it say 31? 35 over 1, that equals 35. That's not the same as the first number. 45 over 2, that's not going to equal 0. It's not going to equal 35. It's going to be a different number. So each time I divide these numbers, I see that it ends up being a different number. We start at 0, then 35. This ends up being 22.5. So 45 over 2. And then if we did 55 over 3, that ends up being 18.3. So if you look over here, all these numbers ended up being the same. 1/10, 1/10, 1/10, right? Over here, these numbers are all different. 0, 35, 22.5, 18, and 3/10. So again, all these numbers are different. This is different. This is different. This is different. That's different. So just by dividing the numbers to see if they're all the same, you can tell that, hey, this is a non-proportional table, right? So if I wanted to make an equation, I would still do the change in y over the change in x. I'm still going to do the same thing. The change in y is 25 to 35. That's 10. The change in x, I went from 0 to 1, so that would be 1. So this is flipped from the other situation. This one we have 10 over 1 instead of 1 over 10. So if I was to make an equation, I could say that even if you call this k, we also call it m. If I was to say that y is equal to 10 times x, right? Just like we did here, we took this number and multiplied it by x, and we ended up getting a y value. So when I input 10 times 1/10 is 1. Okay, 20 times 1/10 is 2. I'm going to do the same thing here. Right? So I'm going to put 0 in. 10 times 0 is 0, but that's not the number we got here. If I put 1 in, 1 times 10 is 10, but that's not the number we got here. If I put 2 in for x, 2 in for x, 10 times 2 is 20, but that's not the number we have here. So I had to think, well, what's happening every single time I put in this x value? If I put in 0, 10 times 0 is 0, and then I end up at 25, I would have to add 25. If I put 1 in, 10 times 1 is 10, plus 25 is 35. 10 times 2 is 20, plus 25 is 45. And so we end up with an equation that says 10x plus 25 in order to get that y value. And even if this is confusing now, which I'm sure it is, I'm sure it's not cut and dry for you right now, you'll understand it later as we go more into it. Right now, we're just comparing the two because as we can see, there's no plus anything here, and there's definitely a plus 25 there. And so you see that plus or minus, then you know that, hey, that's non-proportional. If you don't see a plus or minus here, it's just 1/10 times x, you know, hey, that's proportional, okay? If you look at the tables here, you say, okay, all these numbers are the same. When I divide them, they're all the same. That's proportional. But look at these numbers here. When I divide all these numbers, they're all different. That's non-proportional, okay? If we compare the graph, let's say this is my x-axis. Let's go by ones. So 1 month, 2 months, 3 months, 4 months, 5 months. And then on the y-axis, we'll do 25, 35, 45, 55, 65. Okay. So before I even pay for the first month at 0 months, I still owe $25. So my line starts here at 25. And then the first month is 35. And then the second month is 45. And then the third month is 55. The fourth month would end up being 65. Right? And so my line goes like this. And so since it did not, because we still have the, yes sir, we still have the point of origin here. But the line didn't start there. The line started above it. And so when that happens, when the line does not start at the origin, then we know that this is non-proportional. So if the line, just comparing graphs, if this line goes through the origin like it did here, it's proportional. But if it starts at anywhere other than 0, even if it started a little bit above 0, if it starts anywhere other than the origin, it's non-proportional. And the reason why I started at 25 is because at 0 months, I still owe $25. And that's why we add the 25, because even if I pay 1 month at $10, I still had to pay that initial $25. And so what you guys are going to do is you guys are going to try to answer, I'll do this one for you. And a proportional relationship can be represented by an equation in the form of y equals kx or y equals mx. It doesn't have any addition or subtraction. And a non-proportional is y equals mx plus b, and then that plus b is that plus 25 that we talked about. So again, we'll go more in depth as we get into our unit. Really, I just want you to understand the comparison between the two, the fact that this graph starts at the origin and this one does not, the fact that this table, if you divided all of the values, have the same number, or they have the same value or the same quotient whenever you divide them, as opposed to this one, it has a different quotient every time you divide one of the values, right? Over x. And then if you look at the two equations, we have y equals 1/10 times x. Over here, it'd be y equals 10x plus 25. So we add 25 because of that initial fee. So really, that's what I want you guys to understand is the difference between those two. And then we'll get more in depth in terms of what each of them means. That said, I want you guys to answer these two questions and answer these two questions as well. A proportional relationship must, again, go through the origin, and it must be linear. It means it must be in a straight line. So it must go through the origin, and it must be in a straight line. And then the table is represented by k equals y over x or m equals y over x. And these triangles right here, they're called deltas, and the delta means change. So the change in y over the change in x. And so yeah, I apologize for the video running so long. However, I wanted to make sure I got as much information in here as possible. And then tomorrow we'll kind of go more in depth in terms of all of this, but specifically the proportional relationships, so long as we understand the difference between the two.